got the question there, Kim? Yeah. Are you ready there, folks? Do you not know how to use your phone, Andy?
I press it wrong. V1.
No, V2. V2. Okay, we can start now, yeah. Well, Andy, since you have it open there, maybe you can read the first question to us.
The sled is being pulled along a horizontal snow-covered surface by a piece of string, which makes an angle to the horizontal of 40 degrees. The sledge is pulled at a constant speed for a distance of 200 meters.
What info am I missing in my picture?
19 meters at the arrow.
Anything else? Do you know the mass of the sled?
No.
No, you don't know the mass? Alright. What did they ask for part 1?
What is the horizontal component?
Okay, so that's just 90 cos 40. I hope you got that. If you didn't, you should go home now. 90 cos 40, so what's that? 68.9 meters. 68.9? Yeah. Okay. Uh-oh. Uh-oh. Who is right and who is wrong? Oh no! Maybe you didn't have enough biscuits yesterday. Calculator mistake?
Yeah.
Yeah. Okay, what's part 2, Andek?
Define work done by a force.
So, Siba, what did you say work was?
Work equals force times distance.
Yeah. Yeah.
Force distance.
Yeah, so this is the force applied. And this is the distance in direction of the force. And then the W is the work done. Yeah, okay, what's part 3? Calculate the work. Alright, so that's force. Now, what's the force here? It's the 68.9 because it's only the horizontal component times the distance, which are we told is 200? Yeah, okay. So what did you get here?
I did plus 90.
Plus 90? Oh yeah, because you used the previous number. Yeah. So what is it now?
13780.
So 1380 joules.
1 mark. 0.
Yeah? Okay. Is that the end of question 1? How many marks in total for question 1? 6 is alright. So you would have lost them. Well, I suppose in the exam you would have maybe double checked your answer. You would have lost the last mark. You said you did a plus 90 or something.
Yeah.
What was you thinking there?
The 90.
I don't understand.
The,
No, I know, but why were you thinking the plus 90? Okay. It's just, this is, yeah, okay. Right. Siba, you can read us number 2, please.
A toy rocket is launched using compressed air vertically from the ground. Once it leaves the ground, it behaves as a projectile, i.e. air resistance can be ignored. Its initial speed is 35.0 meters per second.
35.0.
Yeah.
Is it, so let me guess the question. The question is going to be, what's the maximum height?
Yeah.
You see how I knew that? So the U is 35. What's the V?
0.
0. Good. The A?
Times 2.
Yep. The T? Don't know. S? What we want, yeah. Which we don't know. So the formula, which formula should we use to get the S?
V squared.
Yeah. V squared equals, now hang on, don't tell me, 1225 u squared minus 2as. So the s is 1225 over 19.62. What's that?
62.9.
How many marks for that now?
2.
Only 2?
Is that right?
No, that seems...
It's 62.4.
Okay.
4.
So 62.4. Okay. But how many marks though?
2.
Only 2. And there's no other parts?
No, there is.
Oh, okay.
B.
Okay.
Calculate the total time the rocket is in the air before it hits the ground.
Okie dokie. So the U, 35. The V, we don't know. The A is minus G. The T we don't know. And the S we do know. What's the S?
62.4 times 2. 0.
Oh, you did it that way, the way I don't like it. Which is fine. Which is fine. Oh no, 62.4. Did you say times 2? Oh no, not this.
I got the same answer.
Well, what did you say times 2? What is times 2?
Like it's up and down.
Yeah, well, multiply what by 2?
The distance.
Ah! No. If you... No. No. What's the S?
What?
You said the S.
0.
0.
Oh, I did put 0. No.
Okay. Okay, okay.
I crossed it out.
Good! Alright,
Yeah,
good, good.
yeah,
Fine,
so-
fine. Right, so
Yeah.
we have S equals UT plus a half a T squared. I can divide by T and I'll get T equals 35 over 4.905. So what's that? 7.5 seconds? 7.14 seconds then. Okay, is that another 2 marks? Oh, and do you mind getting that? Now who do we think it is? I'm gonna, yeah, Matt. Or maybe Chow. Matt, okay.
Right.
What happened to you, Matt? Ah, must be very late. What time do you wake up at?
10:50.
That is quite late. League of Legends last night? No? Physics last night? No, I don't believe you.
Yeah, he did. He posted on his Instagram.
Did he
Yeah.
posting physics on Instagram? 0 followers. What did you post on Instagram? Okay. Okay. Is there another part, or Siva? Is there a part C?
Yeah.
Oh, there is. Okay. What?
Find the speed of the rocket when it's at 75% of its maximum height.
Oh, for goodness sake! What a weird way to ask it. Right. So the U is 35. The V we don't know. The A is minus G. The T we don't know, and the S is 3/4 times. What was the max height? 62.4. Very weird way of asking it. And what did they want? The V, was it?
Yeah.
So what's the best formula here? V squared equals, yeah. So V squared equals U squared plus 2AS. So you just hit that in on the calculator and you are done. Do you have an answer? 70.5? 17.5? 6 marks? 222?
3, 4, 5, 6, 7.
7 marks. Okay, that's alright. Right. Ready to continue? Kim, can you give us a tree?
Define Newton.
Ah, did you define Newton? Kim. Did anyone try? Did you try to define the Newton, Siba? No? You didn't write anything? Blank? Andek?
Can I do it on the spot right now?
Go for it.
A method of a unit of measurement for force?
No, don't like it. Not this. No like.
1 Newton is 1
Yes?
something, that's right.
Thought you were going to say it there. Now, 1 Newton is definitely 1 something, that's for sure. 1 Newton is the... Well, let's use all our beautiful English. A Newton of force is required to cause 1 kilogram to accelerate by 1 meter per second squared. Now, that wasn't so bad to remember, was it? Was it? Was it? Yes, it was. Do you realise all that's happening in my head is I'm simply remembering this formula that says 1 Newton is 1 kilogram by 1 meter per second. That's all that's happened. Yeah. Okie dokie. What's the next part then, Kim?
If the mass of an object is 40 kilograms, then what is its weight at the Earth space?
So that's just mg, huh? So what's that? 392 newtons then. Okay. Is there more?
Yeah.
Great. What's next?
If the ratio of the gravitational field strength on Earth to that on the Moon is 6 to 1,
Yeah.
what would be the weight of the object if it were on the Moon?
Yeah, that question, we kind of had one like it in the workbook. It's just a very, very complicated way of saying gravity on the Moon is 6 times smaller than on the Earth. Well, like, you might have to revise some ratios here. If you say something's in the ratio of 6 to 1, you're actually saying it's 7 times smaller, aren't you? Like, think about it like this. Well, no, are you? Sorry, I'm confusing myself. 6 to 1, let me remember back to elementary school. That means I have 6 sweets and you have 1 sweet. So you have 6 times less sweets than me. Yeah, okay. So all you have to do is take your 292 and divide it by 6. And what do you get?
65.4.
Okay. Is that like 1 mark?
2.
2 marks. Interesting. Maybe because you had to think about this. Is there more to it? No. Okay. Next one I think is A4. Matt, do you have A4 in front of you? What's the info?
An engineer is designing a bridge, but has to consider the forces acting when a lorry is driven across it. That's shown below.
So is there some picture like this?
Like this.
Oh, I see. So you have your lorry here, and then there's a reaction here. Is that called S1? S2? And then you can tell me, that's okay, thank you, you can tell me the 2 numbers here. So what's the lorry's weight in the picture?
3 times 10 to the power 5.
Newtons. And the bridge's weight?
2 times 10 to the power 6.
What? They're saying the bridge is only 10 times as big as the lorry?
The bridge is
That's not a very good bridge. Go on, yeah.
The bridge is designed to be 80 meters long.
80.
80.
Okay, so, 80 meters for the whole length, right?
Will have a weight of 2 times 10 to the power 6 Newton, and a lorry of weight 3 times 10 to the power 5 Newton is to be placed 15 meters to the right of support line.
Okay, so this is 15 meters. This here is 40 meters from here to here. Yes, that's 40 from there to there. And if here to here is 15, and the total here must be 40, what's that, 25 meters? Okay, so there's all our distances, right?
Find the magnitude of both support forces S1 and S2 on the bridge.
We've seen this type before, haven't we? You say S1 plus S2 equals 3 times 10 to the 5 plus 2 times 10 to the 6. Yeah? That's equal to 3 times 10 to the 5 plus 20 times 10 to the 5, which equals 23 times 10 to the 5. That's S1 plus S2. Okay? Now we have to make a turning force equation. Which turning point will I take? I'll take it here, because I can cancel S1. So first one, clockwise or anti-clockwise? Clockwise, clockwise, anti-clockwise. So you can say 15 by 3 times 10 to the 5 plus 25 times 2 times 10 to the 6. That should equal 80 times S2. So simply dividing by 80, and I've already got my S2. So S2 equals... Thank you, Siba! I screwed that up. I just saw the 25, but it should have been 40. So you're fully awake today. Congratulations. I'm not, it seems.
1.24 times 10 to the power 6.
Newtons. So that's 12.4 times 10 to the 5 newtons. So if I sub that back into here, I can get S1 23 minus 12.4, what's that?
S1 1.24. I know, S2 is...
Yeah.
S2 is 1.06 times 10 to the power 6.
1 S.
S2, yeah.
Oh, sorry. S2 is not 12.4. What is it?
S2 is 1.06
Times 10 to the...
power 6.
So 10.6 times 10 to the 5. Okay. Then the other one will...
S1 is 1.24.
12.4.
1.24.
Ah, yeah, but 10 to the 5. I'm just changing it. Are you sure? Yes, you're correct. Okay. How many marks for that?
4.
Okay. Is there more to it? The B part, okay.
He suggested that moving the bridge supports closer together might reduce the forces S1 and S2. Discuss the effectiveness of this idea. Is it correct? And are there any other advantages to moving them closer together?
Okay. So let's think about what happens. S1 plus S2, that still has to equal the total weight, which we said is 23 times 10 to the 5. That doesn't change. But let's think about what about the turning forces. So imagine S1 moves to the right and S2 moves to the left. And so we move it a little to the right and a little to the left. If we look at our formula for S2, would that 15 be bigger or smaller? Well, the 15 was the distance between the lorry and the first support. So is it bigger or smaller? It'd be smaller. So it'd be a smaller number times the 3 times 10 to the 5. And the 40, well, that would be the same. Because it, no, it wouldn't, sorry. It'd be smaller again. Smaller, smaller. That's still 2 times 10 to the 6. And we divide it by 80. Where did the 80 come from? Would that 80 be bigger or smaller? It'd be smaller, wouldn't it? Ooh, so it's not clear what would happen to the S2 because 3 things in are getting smaller. The question is which is getting... Yeah. Which part of the formula do you think matters the most? If you look at the 3 parts here, which is the most important part? And by most important, I mean has the biggest contribution to the calculation. I kind of think this one here. Like, think about it. This is just something like 80 meters. It's a small number. Maybe it's 70. And what was this? This was 15. Maybe it's 10. Whatever. But because this is a big number, changing this will have a big effect on the total. So I think it would be smaller, the S2. I think the S2 would be smaller.
I think the question they said it would be smaller.
Yeah, S2 would be smaller in total. But was the question, what is the effect? What happens to the S2? Now, it's not all...
It is suggested that moving the bridge supports closer together might reduce the forces S1 and S2.
yeah.
Discuss the effectiveness of this idea. Is it correct, and are there any other advantages to moving them closer together?
Moving them closer has an advantage in that it makes it smaller, but it also has a disadvantage. So before I talk about the disadvantage, can we just check that in the marking scheme it does say smaller?
Incorrect.
What's that?
Incorrect.
It's not, it's bigger.
Total support force must remain the same for equilibrium.
No, hang on. Yeah, no, but no. I said that at the very beginning. I said the total has to be the same. We know that. I thought they were talking about each individual.
Each support force may change if moved.
Okay, sorry. I didn't mean to overreact. So the total remains the same. We've got that. Good. So, point 1, total remains the same. Okay. And then point 2, you said they might change. Okay, so we got point 2. Now, before you tell me point 3, there is a disadvantage. I don't know if they say the disadvantage in the marking scheme. Does anybody know what a disadvantage might be for moving them closer? What might be a disadvantage? Take an extreme example. If you move them too close, so you put them here, what would be the disadvantage with this? Yeah, like you're going to have, if you have the lorry here, it's going to have more of a turning effect. It's going to make the bridge, like take the extreme example that you bring the support so close together that they just become one support in the middle. Would you want to cross this bridge in a lorry? No. So there's a disadvantage if they're too close. That might cause a turning of the bridge, and this would be the extreme example where you bring them on top of each other. Now, do they say that on the marking scheme? Or?
S1 gets greater as it approaches the lorry's position.
Yeah.
Advantage. Stress on the bridge span is less due to reduced moment out to COG.
But it says credit any good points based on correct physics.
Okay, I'll credit my last one there. Because like I said, you don't want to be on a bridge with just one suspension in the middle. Yeah. Oh dear. Right, is that the end of that question? Right, back to Anda. What's the next one now? What number are we on?
A5.
Okay, go for it.
The car of mass 1480 kilograms accelerates.
1480 kilograms, okay.
Accelerates from rest to 20 meters per second in 50 seconds.
Okay, from rest to 20 meters per second
In 15 seconds.
in 15 seconds, okay. Right, and continue.
Show that the kinetic energy gained by the car is approximately 300 kilojoules.
Kinetic energy. What's the formula for kinetic energy? A half mv squared. So that's 740 times 400. 0, 0, 0, 140, 280. Oh, I'm too tired. What is it? The energy, it should be. I'm sure that's what you would get if you multiplied.
Yeah.
Yeah, okay. Is there more? There has to be more.
What is the average power transfer to the car during this time?
Okay, what's the formula for power?
Work over time.
Work over time. So what do you get here?
19733.
19733 watts. Okay, next part.
Oh, sorry.
Yeah.
If the power produced by the engine of the car is 25 kilowatts, what is the efficiency of this process?
Good, so the efficiency would be power out over power in times 100%. So what's that, about 80%?
79%.
79%.
78.9.
Okay, math, 78.9. How many marks for this, Andek? In total?
Here's another one.
Oh, yep.
Suggest a reason for the difference between the kinetic energy gained by the car
Okay.
and the energy produced by the engine.
Right, so why is there a difference? Heat loss. Heat lost through to the surroundings. Okay, how many marks in total for that, Andek?
6.
That's alright. It's alright, isn't it? Okay, are we still on mechanics, the next one, Siba? Another mechanics? Goodness sake. A7. No, A6?
Yeah.
Right, what's the story now?
In a game of 10-pin bowling, a ball of mass 5 kilogram is used to knock over pins of mass of 500 gram. In one game, the ball has a velocity of 10.0 meters per second just before striking a single stationary pin. After the collision, it moves in its original direction with a velocity of 8.50 meters per second. A, state the principle of conservation of momentum.
Okay, so that's M1U1 plus M2U2 equals M1V1 plus M2V2. Where M1 is the mass, the first one, M2 is the mass, the second one, blah, blah, blah. We know this formula, right? What's the next part?
What is the velocity of the skittle after the collision? Give speed and direction.
Now this annoys me about the exam, their English. They're being very, very bad at the English. They were using one noun earlier in the question and they switched to a different noun. So yeah, they were calling it a pin and then they switched to calling it a skittle. It's very poor. Even for native speakers, this is very poor practice to change your noun, you know? It's like if I start talking about my car and my car this, my car that, and then I just switch to automobile and then back to car, you know? It's very poor. Right, so M1 is 5, U1 is 10, M2 is 0.5, U2 is 0, M1 is 5, V1 is 8.05, plus 0.5 times x. And we're looking for the x. Right, so well that's a 0. So that's 50 minus 40.25 over 0.5. That's the x. So what's that? That's 9.75 over... I think I can do this all by myself. Let me see. Don't tell me. 10, 20, 19.5 meters per second. Please tell me I'm right. No, I need a calculator. What's the answer?
The M1V1 is 8.5.
I thought you said 8.05.
8.50.
Oh, I thought you said 8.05. Apologies. Okay, so that actually makes my calculation easier. So that is not. Oh, let me fix this. Sorry. So let me try again. So that's 50 minus 5 times 8 is 42.5. So that should have been 7.5. So that should have been 15. Is 15 what you got, Siba? Yeah. And is there a C part?
Yeah, state and explain if this is an example of an elastic collision.
No. Do you remember what the difference between elastic and inelastic is?
Elastic resistance to its original shape.
Ah, no, you're thinking of plastic and elastic. We're talking about elastic and inelastic collision.
I think we move in one direction.
Where there's a way we can check. There's a calculation we can do.
Same or not?
If what exactly is the same. Kinetic energy, if it's the same or not, yeah. So the kinetic energy at the beginning is a half v squared, which is 100. So that's 50 times 5, 250 joules. Okay. The kinetic energy afterwards is a half v squared plus a half v squared. Oh, do I want to do this in my head? I don't really want to. Maybe someone could kindly type that in. So there's a lost kinetic energy. So what does that mean, elastic or inelastic? If there's a difference, Kim, do you remember if that means elastic or inelastic? Inelastic, yeah. How many marks for that last part? Don't say one, please don't say one.
2.
Oh, good. Okay. What are we on now? A7? Okay. When you're ready, Kim, we'll have a look at A7.
To investigate
Brownian motion.
a small cell can be set up. Our light source is shown through the silk box containing smoke particles, which can be seen as particles when viewed through a microscope.
Okay, so you said it's a silk box.
Sealed.
Sealed box. Ah, okay, not a silk box, right. So you have light here, and the light shines through this box, and I think you said it's full of smoke, wasn't it? Yeah. And you have your microscope here. Smoke particles. Okay, continue please.
Describe the observed motion of the smoke
Ah.
particles.
So, best English now. Kim, want to try describe the motion of the particles you see in here? The particles appear to what? How would you describe their movement?
Move in random direction.
Yeah, appear to... Now we should put in more adjectives, okay? So, good, you've got random. What else can you put in? Let's think adjectives. Or adverbs, even. So, like, let's put more adverbs onto describing their motion. So they move in a... So, is the random movement... We should quantify it. Is it big or small? What do you think? Well, you see, because when you say something moves in a random motion, that could mean this. You know? Or it could mean...
Constant.
Well, we want to quantify the size. So, are we saying it's big or small?
Surrounding the container.
Yeah, it's kind of within the small neighborhood. Okay, so the language here is the particles appear to move in a small random motions. In its neighborhood. And then we could even draw it here. See, that's what I mean by small random, and in the neighbourhood, that the movements are not far away from where it began. Because, you know, you could have big and random, like that. You know, that's not the same thing as that. Okay, so really want to have in some words like small, random, and neighbourhood, something like this, okay? How many marks though, Kim? Two. So 1 or 2 sentences should do. The particles appear to move in a small random motion in its neighbourhood. Okay, I don't think there's anything else I can add. Is there more to the question? Yeah, okay.
Give a conclusion about the nature of matter which can be drawn from these observations.
So, what's our conclusion here? Do you remember? What is the cause of this motion? Yeah, but let's be the air. What precisely did you say? Air what? Air molecules. Yeah. What are they doing?
They are far from each other.
No, not quite this. They're hitting the smoke particle. The air molecules are hitting in what way? So what you can say is the unseen air molecule is hitting the smoke particle randomly. Therefore, the gas, which in this case is air, is actually made of small, unseen molecules. So, in other words, this provides evidence for the what do we call it? The kinetic theory of gases. That gases are actually just collections of little particles. Matt, can you actually read the full... Is this the end of the question or is there more? Can you read the full answer that they gave? Including the A part.
It's one mark. Air particles, molecules.
Oh no, the previous part as well, about the Brownian motion.
Oh,
Yeah.
continuous and random.
That's it, continuous and random, not even a sentence?
Yeah, 2 marks. 1 mark for continuous and random.
Okay, so if you look back at my definition, where would I get my 2 marks? I'd get 1 mark here for the use of random. Did I use any word that makes it sound continuous? The neighbourhood. The idea that it's just moving continuously is the word they used, in a sort of neighbourhood nearby. Okay. Next part?
Air particles must be continuously moving. 1 mark, randomly 1 mark.
Okay.
Motion of smoke particles is caused by collisions with air particles.
Okay, sorry Matt, if we go back to the start, so the first 1 mark was for saying...
Air particles must be continuously moving.
did I say anything like that? I suppose I'm saying... is that kind of like my last point? Okay, continue.
Air molecules are too small to see.
Oh good, I said unseen.
Small movements of smoke particles, so must be very large numbers of air particles.
I don't know. How many marks in total?
1.
And the last one was for saying that there must be many particles of air. Yeah, or that the air is moving very fast, the molecules. How many marks in total? 2, you said?
The party?
Yeah.
1.
Oh, 1. So if but how did they give you the 1 mark? What do you get the 1 mark for? You have to say the whole thing?
No. Either 1.
Oh, okay. So my choices are, I could have said that the air molecules are unseen, is it? And you got 1 mark and finished. So, there, I got my mark on the second word. Okay. Right. Okay, Matt, so now your turn. What's the next one here? A8, okay.
A steel cable is used to lift heavy objects under tension, and extension is produced in a cable. Define strain for a material under tension.
Okay, so guys, do you remember what strain is, the formula? What's strain?
Stress of no.
Yeah, what's the X called? The extension over the natural length, the original length, yeah. So as a formula, you could say it's the extension over the natural length. Yeah. Okay, what's next now, Matt?
If the tension in the cable is doubled, explain what will happen to the extension of the cable. What assumptions have you made in giving your answer?
Right, so they're saying if what is doubled? The extension.
The tension.
The force. Okay, so if you look here, do you remember Young's modulus is stress over strain? So strain is stress over Young's modulus. So that means strain is proportional to stress. And strain, we said, was extension over natural length, and stress is force over area. So if you double the force, it'll have the effect of doubling the extension. But that's only if everything else is constant, which it really should be. The natural length doesn't change. The area shouldn't change. And the Young's modulus definitely shouldn't change. So the effect is the delta x should double as long as the natural length, Young's modulus, and the area remain constant. Now, obviously this is a property of the material, as is this, so these can't change. But actually the area could have changed. Do you ever notice sometimes when you stretch something, it becomes a bit narrower? Do you ever notice that? Like if you pull something tight, it actually shrinks in a little bit. So as long as that doesn't happen, it's fine. Okay, is there more?
No.
That's it? Oh, right. How many marks in total now?
4.
2 and 2?
1 and 3.
1 and 3. 1 and 3? Okay. Strange. Question? Is it okay? Did you get this one? What did you say, Siba?
Quite only this. I just wrote extension is doubled.
Yes.
While assuming it doesn't reach its elasticity limit.
Oh, very good, Siba. I forgot to say about that. That you don't break it when you extend it. I don't think I'll get full marks now. I should have said assume it is still elastic, which is what you said. Rats, I think I would have lost that mark because it was probably 1 mark for this, 1 mark for this, and then 1 mark for saying about it being doubled. Do you have the marking scheme there? So would I have lost my last mark?
Formula for Hunsol.
Okay, 1. Yeah.
Extension is doubled.
Okay, 2.
Assumed obeying Hooke's law or behaving elastically or not past proportional limit.
Yeah, I would have lost my last mark there. I'll have to make do with 99%. So, right. Next now. What's the next one? Who are we on to now? Yeah, you gave me that, didn't you, Matt? So, Andek now. What's the next number? A9. All right. We're flying. Go ahead.
To find the specific heat capacity of a metal block.
A metal bar.
No, metal block.
Metal block. Okay.
Insulated baths of water can be used. A 2 kilogram block of metal A is placed in the water above it.
Sorry, I can't hear you because they're having cookies right now, so just we'll wait a minute.
Should I first start?
That's okay. I just want to get the info. So, did you give me any numbers yet?
Yeah, a 2 kilogram block of metal A is placed in water above at 100 degrees Celsius.
Okay.
And allowed to reach thermal equilibrium.
Mm-hmm.
It is then quickly transferred to a second insulated water bath at an additional temperature of 20 degrees Celsius.
At 20.
The metal block and the water are then allowed to reach thermal equilibrium, and then the final temperature of the water is 135 degrees Celsius.
How much is it?
35.
35 Celsius. Okay.
The mass of water in the second bath is 4 kilograms, and the specific heat capacity of water is 4.9 kilojoules.
This is 4 kilograms of water, and the specific heat capacity is 4.19.
4.19 K.
4.19.
Yeah.
So that's 4190 joules then. Yeah. Because you said kilojoules.
Yeah.
Yeah.
There's like 2 more units behind.
Ah, yeah. It's joules per kilogram Kelvin.
Yeah.
So what's interesting is the story begins by putting the block in boiling water, and the only reason for doing that is to get the block up to exactly 100 Celsius. Okay, so then you take it out, you have this hot block, it's 100 Celsius, and then you drop it in cold water. So what will happen? Well, the block will gain or lose. If you drop it in the cold water, yeah, lose, yeah. And the cold water will gain. Right, so how much energy will the block lose? That will be M, C, which you don't know, and delta theta. Now it went from 100 to 35 in the end. So that's 65 drop. And the water, which is M, C, delta theta, the water warmed up from 20 to 35. So that's 15. So if I just divide that by 130, because that's 2 times 65, I should get my answer for C. Should be a smaller number than, it should be like 200 or 300.
$1933.
1933 is pretty big. Joules per kilogram per Kelvin.
0.8.
So 0.31934. Yeah? Is that the right answer?
They have it as.
Did they put it as...
That's 3. That's question 3.
Huh?
That's part 3 of the question.
Oh, how did I skip part 1 and 2? Did you not read it to me, Andek?
Oh my god.
Alright. Hang on, that's part 3. Okay. So, what was part A?
What is the change in temperature of the metal block?
Ah, that's for babies. The change in temperature of the metal block, it went from 100 to 35. So it lost 65 Celsius, right? Okay, part B?
How much thermal energy is gained by the water in the second water bath?
Oh, that's just whatever this number is on the right here. That's the 4 times 4190 times 15. What's that? 251400 joules. Okay. That's it then. How many marks in total for this question? 5's alright. Because really, you notice I had to do this to answer this. So it's like they gave me bonus marks here, because I had to do this to get this answer here. How many marks for these A and B parts? 1 and 1?
1 and 2.
1 and 2, so it was 1, 2, 2?
Yeah.
Right, okay. Right, A10 now. Siba, when you're ready.
A container of gas is kept at 20 degrees Celsius. Its initial pressure is 100 kilopascal, and the volume of the container is 2 times 10 to the power of -3 meter cubed. A, state Boyle's law.
Boyle said pressure is inversely proportional to volume if everything else is constant, if all else is constant. That's Boyle's law. So obviously what they're doing here is they're going to give you a second part where you're required to use Boyle's law. So what's part B?
If the gas is compressed to a volume of 5 times 10 to the power of -4 at a constant temperature, what will the new pressure of the gas be?
Yes. So you've gone from 2 times 10 to the -3 down to 5 times 10 to the -4. How many times smaller is that? Let's just do a multiplication. So that's what the heck is that? Multiply above and below by 2. So that's a 10. Is that 4? Is that 4? This fraction? So, if V is 4 times smaller, then what happened to P? What happened to P? 4 times bigger. So the pressure now will be 400,000 pascals. Fine. No problems here. How many marks for that? 2? 2 and 2?
So
Yeah.
I use PV.
Yes.
And
Yes.
I got 399,312.
399.
312.
Yeah, because you have to round something. Huh?
But I think in the marking scheme it says just the formula because they have the one mark left in.
Oh, the problem is P1, B1 equals P2, B2.
Well, that's the same thing as that statement amounts to the same thing as this statement. You know, so if I said to you, maybe you should watch carefully, if I said to you x is proportional to 1 over y, that's the same as saying x times y at the beginning will equal x times y at the end. Their two statements are equivalent. Which do you prefer? Do you prefer to think about it like this as a proportional or like this as an equation? I thought so. Because here you have to think more. Yeah, thinking's bad. Okay.
Do I define if I use PV, use like
Yeah, like clearly the intention is 1 mark for the correct equation and 1 mark for the answer, you know. Again, maths, actually PV equals nRT, this is belonging to that formula. Because if I said to you PV equals nRT, from that you can deduce P is proportional to 1 over V. So it's all the same thing. Right, is there more or the next question?
C.
There's a C part?
Yeah.
What's the C part?
If the compression took place at the same time as the temperature changed from 20 to 25 degrees Celsius, what would the final pressure be in this case?
So now I feel like we have to use PV equals nRT. So PV equals nRT. Okay. Now, what did they look for? What are they looking for, Siva?
Final pressure.
Final pressure. P equals nRT over V. Now, there's some things we don't know which we'll have to work out. We don't know the N yet. We know the R, it's 8.31. What's the temperature at the end?
From 20 to 25 degrees.
So it's now 25. So that's 273 plus 25. And what's the volume at the end? It's the 10 to the minus 4 number. What was that? What was that, guys? Guys, it was in the previous part, tell me.
5, is it?
The 10 to the minus 4 number.
Yeah, 5.0.
5.0 times 10 to the minus 4. Okay. So the only thing I'm missing here is what? What am I missing? I'm only missing the N here. Now you can get the n at the start of the question. If you go back to the beginning, where are we gone? At the very beginning, you can get the n here. The number of moles never changes as long as it's all sealed up. Nothing escapes, okay? So if you have PV equals nRT, then the n is PV over RT. So for this one, it would be 100,000, so that's 10 to the 5, times the volume, which is 2 times 10 to the minus 3, over 8.31 times 293. That's the n. Thank you, Siva.
0.082.
Oh yeah, you worked it out because you did it the other way. 0.082 moles. Okay, so if I carry that down to here, 0.082, I'll get my pressure. Second.
406.
Who was reading this to me?
Me.
How many marks was that one?
The last one?
Yeah.
2.
So the total, like 222? Or? Right, that was A11? Alright, so now Kim, A11.
Is this being recorded?
I sure hope so. Yes, it's been recording for 56 minutes now. You gonna like and subscribe later? Okay, A11.
How better with...
No, go on, try and say it. No, don't help her.
I don't know.
Try. Oh, and negligible.
Negligible.
Yeah.
Internal resistance is connected in the following circuit.
Okay, so you have a battery,
10 volts
10 volts,
and ampere.
connected.
Ammeter?
Oh, meter, yeah.
A.
Okay.
And resistor.
Does it really matter where I put the resistor? Like, I'll just put it here. Okay.
And 2 resistor with 12 ohm.
Oh, 2 resistors in parallel.
Yeah.
So actually,
No, that one.
oh, another one.
Yeah.
I see. So there's one here. Do you know how big this is? No. Okay. And then there's 2 here in parallel.
Yeah.
Okay. And how big are they?
12 each.
12 each. Okay. And then is that the end of the circuit?
No, and there is voltmeter.
And a voltmeter. Okay. Connected around the first resistor.
The other.
These 2.
Yeah.
Around both of them.
Yeah.
So like this.
Yeah.
Okay. Right.
That's all.
That's the circuit. Okay. So my guess is, this is my guess, they're going to give you maybe ammeter and voltmeter and ask you for what this is, something like this. Okay, so what do they ask?
The first one is, what is the current reading on the ammeter?
What's the ammeter reading?
Oh, there's a voltmeter reads 4 volts.
Oh, thank goodness, because I didn't have enough information. The voltmeter reads 4 volts. Okay. So look, I think the first thing we should do is combine these 2 into 1. That's the first thing we should do. So let's see. 1 over 12 plus 1 over 12 is 2 over 12. But then you have to get the, well actually hang on, that's 1 over 6. But then you have to flip it upside down. So if I delete these, I can replace it with what? Just 6 ohms, yeah? So I've replaced it with a single 6 ohm resistor. Now, the current is going this way. Along it goes, along it goes, along it goes. It doesn't go down here really because that's just the voltmeter. So it goes along here. So it means whatever the current is here, that's the same as here because there's only one path. So let's see. We can use the formula VIR the I is V over R, which in this case would be 4 over 6, which is 0.667 amps, I hope, is the right answer. Did you get this? What happened?
I didn't read them.
Alright.
I use 10.
Use 10. Oh, you used 10. It is this?
I
Nice.
didn't read the sentence.
Reading's important. Yeah.
I didn't see it.
Alright, what's the next part, Kim?
What is the value of resistor R?
This or here. Okay. So, who can tell me what the voltage is here? If I was to connect a voltmeter here, I could work out a voltage. What would it be? No, you can actually see it directly from the circuit. You don't have to calculate anything really.
6.
Why 6?
It's series.
Yeah, well this is 6 and this one here is 4 and those two have to add up to make the 10. So that has to be 6. Okay. Now if I use my triangle again, I can say OR is V over I. Do I know the V? I do, it's 6. Do I know the I? I do, it's 0.667. So this is 9 ohms. That's for part B. Is there a part C? Okay.
If the battery was replaced with one which did have an internal resistance
Yeah.
with the same EMF,
Yeah.
would you expect the total power
Dissipated?
dissipated to the greater or less?
So I guess the question is really what would happen if you put in a small internal resistance, if you add it to the circuit. So remember the 10 volts, that's equal to the 4 volts plus the 6 volts. Now if you add in another little resistor here, what will happen? Well, you still must have 10 volts in total. But this must be smaller now than 4 volts, and this must be smaller now than 6 volts, because you have some other small voltage added in. Now, this guy here, do you want it or do you not want it? You don't want it. You know, maybe this is a light bulb, and maybe this is a light bulb, and you want the voltage used here. But if this is an internal resistance in the battery, that you don't want, because that's what makes the battery warm. Okay, so this would be a wasted voltage, and these two are reduced. So the desired voltage is reduced. So in other words, your whole system is no longer 100% efficient. In this original picture, there was no wasted voltage, assuming that this is a thing that you want and this is a thing that you want. But now by adding in the small internal resistance, you're making some work done that you don't want. So basically power reduces, I would have thought. The useful power reduces. That's what happens here. What did they say in the marking scheme, Matt? Less power, end of story.
Total R greater, current less.
So short. 1 mark.
What is dissipated?
Dissipated. It's a fancy word that means released.
So,
Like, you could say the students are released from class and enter the canteen. Or you could say the students dissipate into the canteen. The same thing.
so you mean total power dissipated is lesser?
I would qualify that bit. I would say total useful power is dissipated, is reduced. I guess because dissipated means release and the internal resistor is internal, he might not be thinking that that energy is released, is dissipated. But it is dissipated because it becomes heat, which is released. So that's why I like to put in the word useful, that the useful power has reduced. Okay, who was reading that one? Kim. Okay, so what are we on now? A12?
That's section B1.
Oh, wonderful. We finished section A. How long did that take us? That took us 1 hour, 5 minutes. Yeah, that's okay because I feel like the section B questions can be shorter than the section A questions. Andek, are we back to you? What's B1 about?
The car uses springs to provide suspension on each of its four wheels in order to give a comfortable ride.
Yeah.
When the car hits a bump, it may be set into vertical oscillations on its springs.
Okay.
A graph of the vertical displacement of the car is given below.
Alright, so it starts at 0?
Yeah.
And it goes up? Oh, great, there we go. Thank you. And what info did they give you? Did they give you any info on it? No. And did you say T? And what's the other one I can't see, Matt? What did it? V?
Yeah.
Oh, is this for velocity? Okay. Fine. Okay, continue.
A load of mass 100 kilograms is placed in the car at its center of gravity and it is found to be 1.5 centimeter lower than as the springs compress.
Okay, so you have 100 kilograms and you put it in the car and the result is that the springs reduce by 1.5 centimeters. Yeah?
Yeah.
Okay. So A part 1 now?
Yeah, that's A number 1.
A number 1, what are they asking you for?
Show that the spring constant of one of the car springs is approximately 1.64 times.
Okay, so in other words, find the K,
Yeah.
and they tell us what we should get. So what formula do I use here? What's the formula for the force of the spring? Yeah, what's that called? Hooke's law. So you have F. Now what's the F here? 100G. That's equal to K, and the extension is 0.015. However, we have to be careful. There's 4 springs. So think about this. If I have a weight and I have it on one spring, all the force goes into the one spring. If I have a weight and I put it on 2 springs, and I'm just looking at one of the springs, what's the effect of the force? Greater or less? Less. In fact, how much less? Half less. So I think I'll divide this by 4, which is the same as multiplying this side by 4. But I'll keep my 4 here. So I'll get K is 981 over 4, so that's 0.060. So what's that, please?
$16350.
16350. Andek, is that what they said it should be?
Sorry.
Yeah. That's what they said it should be? Okay, go ahead, Andek. Part 2. A2. What's wrong, Ziva?
In the comments it says must see more detail than 16400.
Oh yeah, so don't just write the answer down. Because they told you what the answer is in the question. So you can't just say, yeah, it's 16400 newtons per meter. I totally worked it out myself, trust me. Right, go ahead, Andek, part 2.
What is the spring constant for all 4 springs in parallel as a system?
Whoa, interesting. I'm going to say it's the same. Now, Siba, shock me and tell me it's not the same. Give me some shocking news. What's the marking scheme say?
The question is for 4 springs.
Yeah, they're saying you take the 4 springs and you stick them together in parallel, in series, to make a super big spring. What's the value of K?
It's 65400.
Not the same number.
Times 4.
Times 4.
Same or different number? Like, what's our final answer?
65400.
65400.
Or add spring constants times 4.
Really? 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 I don't believe that. Is it true? Like, is it? I have trouble believing this. Because if you have one spring and you have another spring, look, tell me if I'm crazy or not. If you have one spring and you have another spring, and they're both the same spring, the same material, the same looking spring, and I stuck one on top of the other to make a bigger spring, is that should still be as stretchy, I would have thought, as the two smaller springs. No. You thinking I'm crazy? That's what I was thinking. You would.
Maybe it'll be stronger? Because it's
Yeah, but it's the same material. Do you know? It's like, let me put it this way. Imagine I had a piece of rubber. There's my rubber. And I have another piece of rubber, and I stick it to the end of the first one. Have I made something that's more, less, or the same stretchiness? Or let me put it another way. I have a piece of rubber, and I cut it in half to make two smaller pieces. Like what? Do you know what I mean? He's saying it's 4 times bigger. I'm having trouble believing that.
I'd say it's 2 times.
I don't quite believe it. In fact, I don't believe it so much that I want to Google it. So, can you open up Google?
What should I Google?
You should Google combining spring constant formula.
I was thinking the first one is for just one spring, isn't it?
Yeah.
So isn't it like the same as 4 times of it?
Yeah. But I maybe I misheard on that.
Parallel is like this.
Well, I thought I asked if it's connected in series. The question said it's connected in parallel, is it?
Yeah.
So I'll show you the picture.
So the area increases, so the...
Yeah, hang on, sorry, I misheard you. And read the question again. Are the connecting springs in series or parallel?
Says here, spring constant for all springs in parallel.
In parallel. Okay, that's fine. I thought you said series. Right, so we better just draw that. Do you have that formula? Keep that page open. So look, there's one spring, and if I connect it in series, that means I'm connecting it to another spring like this. I feel like I was right here saying that the total K is K1 plus K2. I think I will stand by that. Is that what it says there? I'm going to say it is. Now,
In series is 1 over K.
1 over K?
Yes, 1 over K equals to 1 over K, 1 plus 1 over K2.
Amazing. That's amazing. That's absolutely amazing. No, sorry, I'm shocked by this because this is a formula that's not in the syllabus. It's not in the formula book, it's not in the syllabus, and it's not in the past exams. So he's just decided to add it in this year. So we better have a brief discussion of it. Thank you for showing me that. So, new formula. So you can connect your springs like this. This is in series. And the formula for the total spring constant is, believe it or not, you said 1 over K equals 1 over K1 plus 1 over K2. And then when they're in parallel, so they make a spring like this, the formula is K total is K1 plus K2. Now I'm actually, although I look quite calm on the outside, I'm very angry that they did that to the students last year, because it means that students were asked for a formula which was not in the syllabus, not in the formula book, and not in the past exam. Just seems like a jerk move. Last year, the students at the school didn't have this exam. That was at another centre. These students had an exam I wrote here. So this is why I didn't notice this problem, because this exam, I only got it this year. It's from the other centres. I don't know if the person who wrote the exam last year is the same person who's writing the exam this year for you, because I noticed on NCUK's website they're advertising a job for an exam writer of physics. So I don't know if that means that they got a new exam writer. I guess you'll find out when you do the exam if it's someone different or someone the same. I think you're hoping for someone different because you don't like the explainy questions. So we'll find out. Right, back to the question. Did you write those two formulas down? Okay. Oh, slow down. I haven't added them together yet.
Oh, sorry.
Oh no, we'll add them together. So the K is 32800. Was that it? Roughly.
65400. You have 4.
Oh, there's 4 of them, so I have to add them 2 more. Okay, so what did you get there, Matt?
65400.
Newtons per meter. Okay, continue. Part 3, and yeah.
Okay. If the total mass of the car and load is 1100 kilograms.
1100 kilograms, yeah.
Find the natural frequency of the oscillation.
Okay, so that's the F equals 1 over T. Does anybody remember the formula for the T when you have a spring? It's 2 pi root M over K. Yeah. So this here is going to be 1 over 2 pi root K over M. Okay, so what's that, please?
So can I write 1 over F equals to 1 over...
Of course you can. No? You alright? So you know what this means now. It means for the January students I have to teach them that formula, which means the mechanics section has just gotten bigger by 1 lesson.
1.227.
1.23 hertz. Okay, next part, Andek. Is it a part B?
Yeah.
Okay.
Steady conditions necessary for simple harmonic motion.
So in other words, what's the definition of simple harmonic motion? So does anyone remember simple harmonic motion? Yeah, that's the one. So can we have a sentence? Something, yeah, go on.
Proportional.
Proportional, good. Something, proportional, something. We'll say that the force is proportional to the displacement and directed towards the origin. So, in other words, opposite to displacement. Okay, what's next? And that part B2? B2.
Sketch a graph starting and ending at the same time as this graph above to show the vertical displacements of the car.
Okay, so how many, in the original graph, Matt, you had there a second ago, did I draw the right number of periods? How many periods are there? So I have 1 period, 2 periods. Okay. Right, so we have to think about the spring over 2 periods. So the car comes along and hits a speed bump. What happens to the spring? Goes up or down at the beginning? I think down, yeah. So if it hits the speed bump, it compresses. I would have thought. Like, if you think about a car going over a speed bump, you know, the wheel gets pushed into the car and the spring compresses. So I actually think that at the beginning it goes negative. So it should be 2 periods going down. So that's 1 period, and that's 2 periods. So I think that's what it should look like. Am I right? Am I wrong? I'm right? Okay. You had it the other way?
Start from 0.
Going up? Part C? Part C, Anda? Or B?
That's B3.
B3, okay, what's that?
Sketch a graph starting and ending at the same time as the graph above to show the vertical acceleration of the car.
Oh, another graph. Goodness, okay. So, the acceleration, you know Newton said F equals ma, so that means acceleration is proportional to force. So when the force is big, the acceleration is big, and vice versa. So it's not clear what positive and negative is here. At the beginning, the spring compresses. So if the spring compress, are they asking for the force? What precisely force do they want?
They're just saying that starting and ending at the same time as the graph above and to show the vertical acceleration of the car.
Okay, no problem. So you remember, if we go back to the beginning, this is a time velocity graph. What does the area represent? The distance. And what does the slope represent? The acceleration, which is what we want. At the beginning, is the slope positive or negative? It's positive. And does it increase or decrease as we move up the top? It decreases. Because when you get to the top here, what's the acceleration? Acceleration becomes 0 because it's 0 slope. So we go from positive to 0. So if I draw that graph, I think it will look like this. Positive to 0. So there's 1 period and there's 2 periods. And that's what it should look like. Am I right? Do I get my 2 marks? Okay. In fact, actually, I think I showed you these 3 graphs in the lesson on simple harmonic motion. I had the 3 of them. Okay. Right, part C.
In reality, the car will have dampers attached to each spring. What is the effect of the damping of an object in simple harmonic motion?
Yeah, so the dampening is when it goes like this. So basically, you reduce the amplitude over time. So the amplitude is getting smaller and smaller as the time goes on. That's the effect of the dampers. See part 2, or is that the end?
There's D.
Oh, D, okay. I'm getting tired of this question. What's next?
D1 and D2.
Right, D1, okay.
If the car is driven at a constant speed over a series of regularly spaced bumps,
Okay, yeah.
it can cause resonance. Explain what is meant by resonance and describe how this would affect amplitude of the oscillations.
Does anyone remember resonance? We did it on this lesson. No? So do you remember you had, okay, so imagine here you have your spring moving like this, okay? And then you apply a force to try and make the spring move more. So you grab it and then you try to shake it so that it has a bigger amplitude. Do you remember what is the best way to shake the spring so you get more amplitude? Now, it's not what you think. You might think, oh, if I shake it really fast, I can make the spring go further left and right. It's not this. Does anyone remember what the key for making it have more amplitude? What exactly is the same? Not the direction. Same frequency, yeah. So if you can apply a force at the same frequency as the harmonic motion, you will cause the amplitude to increase. This is called resonance. So what you would need to hit the bumps at the same frequency. Now, I think that they asked you to work out the frequency earlier, didn't they? What was it? 1 point something hertz. 1.23 hertz. This will cause an increase in the amplitude, i.e. The resonance. So the picture is like this. This is the harmonic motion. But then if you apply a force at 1.23 hertz, then what will happen is the motion will go like this. If you can hit the speed bumps at the same frequency, you'll cause the car to resonate, which means that basically it feels like it's bumping up and down more in amplitude. How many marks was that D part 1, Andek?
2 marks.
Yeah, okay. Now, hitting the speed bumps at 1.23 hertz, that means per second you hit, no, in 1 second you hit 1.23 speed bumps. Or to be a little clearer, in 10 seconds you hit 12 speed bumps. Which is pretty a lot. Yeah. So I don't know if you've ever seen them. They're called rumble strips. Have you ever seen the rumble strips on the road or felt them? They look like this.
Or are they like smaller speed bumps?
Yeah, well they're very small. What they do, over some distance, they paint. It's only paint, but the paint is painted so that you will hit each one, I guess, at this frequency. So even though when you're driving, you look and you think, oh, it's only paint on the road, it causes a lot of vibration in the car when you drive over them. Have you ever been in these?
In video games, they slow your car down.
Okay, are these?
Yeah, or when you're coming down from a highway, then you feel.
Yeah.
Yes, that's exactly it. They are trying to make the car resonate. So it feels louder than you think it should because you have this resonance going on. Yeah. This was interesting. Right, what's part 2?
Sketch a graph to show how the amplitude of a driven oscillating system varies with frequency.
Hey, I've done that by accident. Okay, read it again. I interrupted you.
The whole thing?
Part 2.
Yeah, the whole.
Yeah.
Sketch a graph to show how the amplitude of a driven oscillating system varies with frequency, and showing your graph shows the natural frequency on its frequency axis.
Okay. What? Sorry. Read that again. Sorry, Andek.
Sketch a graph to show how the amplitude of a driven oscillating.
Pause. Okay, so the amplitude goes here.
Varies with frequency.
Oh, I get it now. Varies with frequency, and there's a natural frequency here.
And
Okay.
the graph shows the natural frequency on its frequency axis.
Okay. So the question is, how do you make the amplitude the biggest? You should choose a frequency that's equal to the natural frequency. So that means on the graph here, this is where you get the most amplitude. Now what happens if the frequency of the speed bumps is increased or decreased? Do you get more or less amplitude? You get less, because remember we just said you get most amplitude, as you said, Kim, when you match your frequency to the natural frequency, which in this case is 1.23 hertz. So anything to the left and the right must be less than that. So yes. So if you have a frequency of 0, that means you're not applying any external force. So you should just have the normal amplitude. So I think the graph will look something like this. That's pretty ugly. Maybe some kind of quadratic shape. How did they draw it in the marking scheme?
Relatively flat below and above at 0.
Okay. Yeah, okay, there you go. Relatively flat and relatively flat and relatively flat. I don't know. Do they have an actual picture? Ah, for goodness sake, okay. Right, is that the end of B1?
Yep.
Right, this is a stinker of a question. It's boring. Right, what's B2 about?
Electricity.
Okay, now we won't have time to do B2, but can I just have a look to see if there's any hard parts I can tell you about? So, part A is just capacitors, and that's fine. And part B is capacitors in series and parallel. In fact, this looks like a really straightforward question. It's all just about capacitors in series and parallel. So that's a nice one. I don't think you'll have trouble doing that, except for maybe part 1 to find the Coulomb. What's up, Siva?
He likes explaining.
He does. Yeah. And part 3. What? There's no materials question. It's just another mechanics question.
Second.
Yeah. You would do 2 and 3? I agree with you. No, I disagree with you. Sorry. I would do 1 and 2.
3 is
You, huh?
3 is
Harder than 1? Yeah. I would do 1 and 2. You would do 2 and 3? Not 1. Look at 3. Look at that picture. That doesn't scare you?
The
Okay, I
formula books don't have the circular motion equation and
They don't?
and they don't have like t equals to 2 pi.
Oh, I know they don't have that one, yeah. But they always add formulas in every year, so the one you get at Christmas exam might have it in it. Because they update it every year. So if somebody last year said it was missing, they might put it in. Yeah. Hey! We don't have any more physics, right? But I could do these when we come back after the break. Because we'll have a little bit of time before the exam, right? Do you have your timetable?
Yeah. For after the break.
Yeah. You don't. As long as the physics isn't on the first day, we can do a bit more revision before the exam.
Did you guys get the AAP timetable?
No.
No.
So have we come for AAP or not?
I think you will send us later. Maybe.
I don't want to cover.
What's the AP stuff going on?
Meeting. One meeting.
The meeting.